is the first thing that comes to your mind?
Pythagorean theorem.
The Pythagorean theorem. So that's what we're going to start with. So when I talk about the Pythagorean theorem, I talk about a right triangle that has sides A and B and hypotenuse C, right?
Yeah.
Our Pythagorean theorem has a relationship that says that a squared plus b squared is equal to c squared. So the sum of the squares of my legs equals the square of my hypotenuse. This is not new to us, correct?
Really? Wow.
I'm going away.
I can give you a mechanical
Jerry?
I can give you a mechanical pencil if you want. Oh, now you tell me.
Okay. So before you had trigonometry, we thought about Pythagorean theorem only in terms of right triangles, right? But now that we've had trigonometry, we can expand this to think about a right triangle within a circle, right? So let's say, for example, if I have
So do we use the radius circle?
this triangle created by that angle. I know that on this triangle, my hypotenuse is equal to 1, right? Because that's my unit circle. I know that my adjacent side to this angle is my x coordinate, and I know that my opposite side here is my y coordinate. Because x corresponds to the horizontal movement, and y corresponds to the vertical movement. So what I can do is I can replace those A and B and C with x and y and 1 respectively, and rewrite the Pythagorean theorem in terms of my unit circle values. So instead of having a squared plus b squared equals c squared, I have x squared plus y squared equals 1 squared. I know 1 squared is just 1. So my new Pythagorean theorem is x squared plus y squared equals 1. Are we okay with that? Do we see what I did?
Yes, sir.
So we can actually take this one step further. Because I know that the x of any angle within my unit circle is equal to which trig function? What does x equal, Jonah?
1.
Go back and look at your notes. What does x equal to in terms of my unit circle? Cosine, good.
Oh, that's
Then what is sine equal to? Oh my gosh. What is y equal to?
Sine.
Sine. So now I can take this Pythagorean theorem one step further and replace the x with cosine of theta and the y with sine of theta. So now my Pythagorean theorem reads cosine of theta squared plus sine of theta squared equals 1. Of course, that's really ugly to look at, so they came up with a notation change for squares or cubes or fourths when I'm talking about trig functions, and we write it as cosine squared theta and sine squared theta. So I just move that exponent so it's only attached to my trig function and not the angle. Do we all see what I did there? Is anybody confused by how we got from our original A, B, and C Pythagorean theorem to this Pythagorean theorem? This is our first Pythagorean identity.
How many we got?
3.
Oh.
So this is the first Pythagorean identity. You're definitely going to want to square that or box it in or circle it or star it. We're also going to write them again at the end of the notes, but it's not a bad idea to see where it comes from. Yes, Stephen?
Is this going to be a video online?
Yes, I'm recording it right now.
Okay.
Is everybody okay with how I created this Pythagorean identity? So now we're going to look at some other identities that will help us create the next 2. So we're going to identify what our reciprocal identities are. I'm pretty sure we've gone over these already, so these shouldn't be 100% new to you. But we're going to formally write them out so that they're in one place. So our reciprocal identities, just go ahead and relate our trig functions to each other. So for example, I know that sine of theta is equal to 1 over cosecant of theta. And I know cosecant of theta is equal to 1 over sine of theta.
Is the reciprocal identity like the second Pythagorean?
No, we have not found the second one yet. We're going to use these to find the next 2. I know that cosine of theta is equal to 1 over secant of theta, which means that secant of theta is equal to 1 over cosine of theta. So these are just our opposite trig functions that we already kind of know about. I also know that tangent of theta is equal to 1 over cotangent of theta. And then I know cotangent of theta is equal to 1 over tangent of theta. These are our reciprocal identities. There's another set of identities that we're also going to write here. And these are called our tangent and cotangent identities.
Can you give us like one second?
I'll write really slow. Does that help? I'll just pause.
Keeping my hands sore. I can't breathe without my mask being on. But I'm writing.
So the next identities we're going to write are our tangent and cotangent identities. There are only 2 of them, so it won't take up much space. The first identity is our tangent identity, and it says that tangent is equal to sine over cosine. The cotangent identity then is just the reverse of this one. So cotangent is equal to cosine over sine. If there's an exponent on, say, the tangent, so if it was tangent squared theta, that exponent will carry over to the fraction, and vice versa. So if I had a fraction here, like sine squared over cosine squared, that would mean that my tangent was squared as well. So the exponents carry through. So we're going to use these reciprocal identities and these tangent and cotangent identities to identify my next 2 Pythagorean identities. So I'm going to minimize this a little bit so we can keep them here. So to find the next 2, I'm going to have to start with the first one that we have, which is sine squared theta plus cosine squared theta equals 1. So I'm kind of curious. I have this Pythagorean identity in front of me, but I wonder what would happen if I divided sine squared theta out of all of my terms. Since I'm curious about it, let's test it and see what happens.
You would just have one.
So I'm going to divide sine squared out of all 3 of these terms and see what happens. Hold on. Just write it. I'm going to give everybody a chance to look at it. And we're going to break it down term by term.
You know, I won't lie to you about what Devin said. I agree with him. Who wonders about that?
What is sine squared over sine squared going to equal?
1.
1, because they
One.
cancel. They are the exact same thing. So this term is going to become a 1. What about cosine squared over sine of squared? Sine squared.
Sine squared over sine.
Nope.
Sine squared.
Cosine squared over sine squared. Jonah? Cotangent. I have an identity right here that says cotangent equals cosine over sine. This is the exact same, but since these are square, the cotangent will also be squared. So this is equal to cotangent squared theta. And then the last one I need to look at is 1 over sine squared theta. That has a 1 in the top and a tangent trig in the bottom. So it's going to be a reciprocal identity. 1 over sine is equal to cosecant. Sine is squared, so cosecant is as well. So when I divided all 3 of these terms by sine squared theta, I get my next Pythagorean identity. That is 1 plus cotangent squared theta equals cosecant squared theta. So this is my second one. Do we all see what happened here? Do we all see how I was able to change these fractions into these new terms?
So those can be anything, like that cotangent could be like
1 over 3. Or like. So would you get another one?
Hold on. One question at a time.
well, I'm saying like could it be like another identity?
So cosine over sine? Are you saying like this one or cotangent itself?
Yeah, could cosine over sine, could that be like sine over cosine? Would that be just normal?
Well, if it was sine over cosine, then yes. But since we have to read it top to bottom, so it has to match exactly. So this one was only cotangent. If it was sine over cosine, then it could have been tangent.
Yeah.
Yeah. So actually, let's do that. On this one, I divided by sine. Let's see what happens if I divide by cosine. So again, we're going to start with our original Pythagorean identity, which is sine squared theta plus cosine squared theta equals 1. And instead of dividing by sine squared, I'm going to divide by cosine squared and see what happens.
Want me to write this down?
Yes. On your own, try to simplify this using our reciprocal and tangent cotangent identities. Devin, what does sine over cosine turn into? Tangent, because I go and I look and I say tangent. Yep, it's sine over cosine. Since these are both square, the tangent will be as well. So this turns into tangent squared theta. Jeremiah, what about cosine squared over cosine squared? 1, because the top and the bottom are exactly the same. And then Cassie, what's 1 over cosine squared going to be?
Secant squared.
Secant squared. So I go to my reciprocal identities. I find the one that has cosine in the bottom, and yes, it's equal to secant. Cosine is squared, so secant is as well. So as you probably already guessed, this is our third Pythagorean identity.
Oh, I looked at the wrong one.
So I'm going to rewrite all 3 of them so they're all in the same place. Just so it's really easy to go back and reference them. So my 3 Pythagorean identities are sine squared plus cosine squared equals 1. Then we have 1 plus cotangent squared equals cosecant squared. And then we have tangent squared plus 1 equals secant squared.
Can you start it up when you're done?
Yes. So these are our 3 Pythagorean identities. We're going to use these a lot. Not today, because I just kind of wanted to ease you guys into it. But we are going to use this when we start doing trigonometric equations and proving identities. My favorite thing. Do we all see how we created these 3 Pythagorean identities? Okay, this is a close second. Anybody confused by how I created these?
You can't have favorites.
Disagree.
Yeah, I like
Addition.
addition.
This is all we're doing today. I was just trying to introduce to you the concept of manipulating trig identities to simplify equations into what I needed and to identify what our 3 Pythagorean identities are. So there is no homework associated with this because there's really no problem that we solved. And the rest of this time is yours to use as you